all of you properly? Yeah.
Yes, sir.
So now this particular session goal is understand what is Six Sigma capability. And a very, very important question. People say, Six Sigma and many times, but what is exactly Six Sigma? Six Sigma is a measure of the capability. So when I say 4 Sigma capability, what does it mean? When I say 3 Sigma capability, what does it mean? So very, very important question. So we are going to discuss right after this lunch. Right. So I have a slide now. This is a ring of fire. Suppose if I want you to jump inside the ring of fire, right? I want you to jump inside the ring of fire. And you all know the ring of fire is circular, right? There are several points inside the circle. And tell me which point you will prefer inside the circle. Or no, jump is safe for you.
Center.
The center.
Beautiful. So this central tendency, this is called central tendency. Tendency will tell you where are you attacking. Central tendency will tell you where are you attacking. As far as the ring of fire is concerned, you want to attack the center point. You want to make sure every time you jump, you actually jump through the center, right? So why did you prefer the center? Because the risk associated will be very low at the center. Am I right? The risk associated will be very low at the center. Because when you move away from the center, then you will approach the boundary of the ring. At the boundary of the ring, there is a fire, isn't it? So it is the same way in your business process also. You must understand what is the kind of output your business process is trying to produce. You will get answer to the question if you know the central tendency of your business process. Central tendency of the business process, right? Central tendency of a business process can be measured using parameters like average, we call it mean, median, or mode. We'll discuss all these things one by one. And suppose when see the center is just one point. I want you to jump multiple times. I know it will for you to jump at the same point. So I'll make the job easier for you. I'll give you some allowance. You jump, but you see that you are jumping inside the circle. See, this circle is marked around the center. And now you are making multiple jumps. If you make all the jumps through this white color circle, every time you are playing the game very safe. You are not being hit by the temperature. But what happens when you are repeating any task several times? Slowly, your capability will go down. Same thing is applicable in business also. You might have the equipments, machineries, you will train the people, but what will happen over time? Their capability will go down. Machines will undergo wear and tear. The raw material qualities will start varying. The people will deviate procedures, and all those things will happen. That means, if you jump several times, there is a chance that you can even jump outside the white color circle. White color circle is safe for you, but definitely when the number of jumps are increased, some of your jumps will fall in the yellow region. Again, when I further increase the number of jumps, some of the jumps will come in the orange color zone. Now you can continuously jump in the white color circle, or you can have some variation, and sometimes you can come to the yellow region, sometimes you can come to orange color region. Now tell me, which region is more riskier as far as the jump is concerned? White is more riskier or the orange is more riskier?
Orange.
That means if you see orange color, any point in the orange band is at more distance from the center, right? That means when you move away from the center, the far you move away from the center, your risk is going to increase. The risk at the white color circle is minimum. The risk at the yellow is moderate. The risk at the orange is maximum. If you go out of the orange, then you're falling on the fire. So that means your data points can help you to understand two things. One is central tendency. Where are you targeting? Central tendency will tell you whether you are targeting correctly or not. Another thing is the amount of risk you associate in the process. What is risk? The deviation from the center. If you deviate a lot from the center, your risk is going to increase. So the deviation from the center can be is called the variation. That variation can also be measured. If the variations are higher, risk will be higher. So variation can be measured in terms of standard deviation, in terms of range, in terms of variance, right? Anyway, all of them will lead to same conclusion only. And out of the measures of central tendency, mean, median, and mode, let me talk about the first one, mean. Mean, average. Similarly, the variation, there are three metrics. What are those? One is your standard deviation. Another one is variance. Another one is range. Let me talk about the standard deviation initially. Right. So now, this is the formula for standard deviation. All of us have studied. Square root of summation of x minus x bar the whole square divided by n minus 1. What is this x bar? Nothing but the average. You all know average. You sum all the number, divide by n, you get the average. And this is nothing but individual data, where n is the number of data points you have. Summation of x minus x bar the whole square divided by n minus 1, and then you take the square root. Standard deviation tells you how close or how far the values of your data in relation to the center or in relation to the mean. Right? All of you understand the two things. One is average. Average will help you to understand the central tendency. And standard deviation will help you to understand the variation in the data. If the variation increases, the risk also increases. That means failure is very close to you. If the standard deviation, if you allow the standard deviation to increase. Right. So now you look at my graph here. You see, a triangular shape. You see a triangular shape, and I draw a center line in the center. When I draw a center line in the center, are you able to see some symmetry here? What you see on the right side? No, you get the same shape on the left side also. That means this triangle is symmetrical about the line drawn at the center. Is it okay to all of you? When I draw a line at the center, the triangle is divided into exactly two of. We call it symmetry. Is it understood by all of you?
Yes, yes.
Very good. So this, so the triangle is divided into two of. So I write 0.5 on the right side, 0.5 on the left side. That means half of the triangle is on the right side, half of the triangle is on the left side. Now I am removing one portion of the triangle. I have a small one kind of bell shape. Half of the bell I am showing. I remove the another half of the triangle also. That means you are able to see the other half of the bell shape also. It looks like an inverted bell. Now imagine a straight line here. When I draw a straight line, is your curve symmetrical about the center? Is this bell shape also symmetrical at the center? Or no? If I draw a line here, will it divide your bell shape curve into exactly two of?
Yes.
Yes.
So that is one important property of the bell shape curve, normal distribution. I have written here. Curve is symmetrical at the center. If I draw a center line, let me also draw it for you. So I'm drawing it here. Oh, it's 1 second. Give me a minute. I'll draw. So I'm drawing a center line. Okay, it's not drawing. Yeah, it is drawing. So I've drawn a center line. Now the curve is divided into two of. What will be the percentage of curve on the right side? 50%. Another 50% on the left. I call the 50% as 0.5 on the right side and this 0.5 on the left side. Hope all of you understand why I'm writing 0.5. 0.5 half of the curve on the right side, half of the curve on the left side. Now what is there on the center? On the center is the central tendency. On the center is the central tendency. That is nothing but average. See, if you really want to understand how your business process is performing, you just go to the process where you actually produce the product, where the service is offered, collect the data. And after collecting the data, let's say you have 100 data. With 100 data, when you visualize, you will be definitely able to see this kind of shape getting formed, the bell shape. Then you can understand your process data is normally distributed, right? Once the normal distribution is understood, you just have to calculate two things. One is central tendency, which is nothing but average. 100 data you have, add all the 100 data, divide by 100, that will give you the central tendency. Then with 100 data, use this formula, you will get the standard deviation. Now, what can you understand using the average and the standard deviation? So average will definitely be at the center. It is the point average which will divide the curve into two half. Now when you move away from the average, let's say moving away from the average by a distance equal to sigma. Now this point is mu plus sigma. Because mu is the center, the distance you moved from the center is sigma. So this point will be mu plus sigma. Now you move further. The distance will be sigma here. Here is 1 sigma. And this point is called mu plus 2 sigma. The mu plus 2 sigma, we call it, warning limit. What is warning limit? The cover, the curve, only a small portion of the curve is available beyond warning limit. That is what you understand. Now you are still moving away by another distance. Now how much distance you moved away from the center? Sigma. How many sigmas you moved away?
3 sigma.
3 sigma. Now this point is called control limit. We call it control limit to tell you that, or to indicate that you have covered 9.73% of the curve. There will be a control limit on the right side. There will be a control limit on the left side. Both will be at a distance of 3 sigma from the center. This control limit will be called upper control limit. This control limit will be called lower control limit. If you identify the control limits of your process, you can now comment about 99.73% of the output your process is going to produce. All of you are with me on this? The moment you know the upper control limit and the lower control limit, now you can comment about the 99.73% of the output your process will produce. So that is why I have written this statement. 99.73% of the points will lie inside 3 sigma limit, nothing but control limit or extremities. These are two important properties of normal distribution. What are the two properties you learned? The normal distribution curve will be symmetrical at the center. And how to locate the center? Average will locate the center. Then control limit, inside the control limit, 99.73% of the points will definitely lie. So with these two properties will help you to understand how your process is behaving currently and how the same process is going to behave in the future, right? Probably when we discuss few more things, you will understand. Now imagine, now there are about 15 of you attending a training program. I wanted to make a guess, or I wanted to predict what category of people will join my black belt training program. So I take a sample of 6 people from you, 6 people. And you people are telling me that your age is like this, 39, 30. We can even do a real-time study after this calculation. So six people's age are marked here. Now what is the average age? 38.5. That means when the average age of the participant is 38.5, that means approximately half of the people are going to be above the age of 38.5 and half of the people are going to be below the age of 38.5. How am I telling this? Based on the normal distribution, because I know most of the data, even age is a continuous data. When that is plotted, that will follow normal distribution. You will be surprised to see when I measure height of all of you, then there will be average height. Definitely half of you will be above the average height, half of you will be below the average height. Not only height, your weight, your pressure level, your sugar level, or similarly in a business environment, the dimension or the material characteristics or any characteristics. If you measure it, that will follow normal distribution. So the average is 38.5. Now I want to know the deviation. What is deviation? Distance from the center. This particular point 39, how much distance it is far away from the center? 0.5, right? 38.5, this is 39. So this will be 0.5. Similarly for this point, minus 8.5. This point, 3.5. Do you all understand how these numbers are coming? 39? Very good. 39 minus 38.5. Similarly, for 40, it is 1.5. Here only it is minus. Now the total deviation, when you sum up, it will come 0 here. Because deviation can be plus, deviation can be minus. That will cancel each other. Always this will come 0 here. Since you are getting total deviation 0, it doesn't mean there is no variation. There is variation. But thing is, mathematically, it is cancelling each other. So I don't want to allow the variation to vanish. So I will square the deviation. That is called squared deviation. X minus x bar will be squared. Minus 0.5 will become 0.25. 8.5 will become 75. Now the minus will also get converted into plus. That's the beauty of max. Now when I sum up, I get 91.5. What is this 91.5? Sum of the squared deviation. Sum of the squared deviation now should be divided by n minus 1. What is n here? There are 6 data. So n minus 1 will be 5. That means I am calculating approximately the average of the deviation. Average of the deviation is nothing but sum of the squared deviation divided by n minus 1. So how much I am getting? 18.3. This 18.3 is called variance. 18.3 is called variance. Now I am going to take square root of the variance. When I take the square root of variance, it comes 4.27. Square root of the variance is nothing but standard deviation. This is the calculation behind standard deviation. Very simple. You have all the data, calculate average. And find out the deviation from the average for each data. Sum up, it will definitely come 0. And then you square it. And the squared value you sum up. And for the summed up value of the squared deviation, divide by n minus 1, that is called what? Variance. When you take square root of the variance, that is called what? Standard deviation. All of you understand how standard deviation is calculated? I need an yes.
Yes, sir.
Yes, sir.
Very good.
Yes, sir.
Why we have calculated standard deviation? I want to predict. I have only a sample of people, attending my training program. But next 1 year, group of people will attend our black belt training program. That is the question I want to get answered. So I will use the standard deviation. I will use the average. I will calculate control limit. What is the formula for control limit? Average plus 3 sigma. This will give me upper control limit. Upper control limit is how much? 52.16. Similarly, I will calculate lower control limit. Average minus 3 sigma, 24.4. Now I will make a statement. People in the age group of 24 and 53 are expected to attend my black belt training program. Is there anybody here less than 24? Or anybody here more than 53? There.
No.
Okay. If it is no, then the formula is working well. Data, is key. Otherwise, when we actually collect your data, you will be able to see this rule definitely working good. So the extremities, the extreme outputs can be predicted by knowing the control limit, upper control limit and lower control limit. Upper control limit and lower control limits are nothing but the extreme outputs. If you can control the extreme outputs, it simply means you are controlling everything. Am I correct? If you can control the extreme output, make the extreme output acceptable by the customer, then obviously the customer will accept all other things, right? So this is how you make your process predictable. All right. So average is a measure of central tendency or variation. What is your option here? What do you think? Average is a measure of central tendency or variation?
Central tendency.
Very good. Average is a measure of central tendency. And then standard deviation is always a positive value. Is it true or false?
True.
Positive, right? Positive, true only. Very good. And what proportion of points are expected to fall inside control limit? What percentage? 68% or 95% or 99.73?
99.73.
99.75.
Very good, very good. 99.73. So write all these things in a bigger font in your walls. We are going to frequently use all this information throughout the program. Very good. Now, moving on. Let us understand customer tolerance and process tolerance. And I'm going to play a short video. Just a second, I will share the video with sound. Then I will ask few simple questions. Yeah.